So this is note-taking guide 8.3. We're going to extend our trig functions to central angles and general angles. So here we go looking at this first triangle right here, and it asks you what's the tangent of A. Do you guys remember that the tangent is the opposite over the adjacent, right? And we've been doing that for a few days now. So the opposite side is 4. And the adjacent side is 3. So our tangent would be 4 over 3. Everybody's good with that? All right, this time it says, what is the tangent of theta? So this angle over here instead. Does anybody know what angle this would be? It would be 180 minus that one, right? To get this angle over here, it would be 180 minus that. So let's do a little experiment here for just a minute and let's see if we can figure out what's happening here. Let's say, for instance, that angle right here, let's say that angle is, I don't know, what do you want to say, 30 degrees? Is that okay if we say 30 just to pick a number? Okay. And then this one would be 150 then, right? Do you guys agree with me on those two? That those would be the two angles. Do you agree with me if we just randomly picked one? Let's just do an experiment here and let's figure out what the tangent of 30 degrees is on our calculator. You guys go ahead and tell me what it is when you get it. Yeah, I'm going to leave it the square root of 3 over 3, but it's what did you say it was? It's, yeah, 0.577. Now we do the tangent of 150 on your calculator for me. Yeah, so do you see that the actual number is the same, only the sign in front of it is different? Are you following me on that? So we're going to use that information to figure out angles that are in the quadrant or the coordinate plane in different quadrants. And we're just going to use, do you guys agree with me that I could totally use this angle to find the tangent of that angle as long as I know which sign to put on when I'm done? Yeah, so I'm going to show you how to decide what sign to put on. But anyways, the tangent of the angle would be the square root of 3 over 3 with the negative sign in front of it because of just the way that it worked. If we used, I guess I didn't use those values right, but assuming that I didn't, I just made up my angles and went with that. That's the way that it would work. I didn't use the numbers 4 and 3, and I should have to show you how that works. But the point being is this, and maybe we should just work it. If I'm finding the tangent of angle A, this was 4 and that was 3, right? So it would be the opposite over the adjacent. So it would be the tangent of angle A equals the opposite, which is 4, over the adjacent, which is 3. And I would inverse tangent that to find the answer. So do the inverse tangent on your calculator. And the angle would be 53.1 degrees, 53.13. So then you could find this angle and then you could find the tangent of it. Are you following me on how to do that? Like we could step through that. So you would do 180 minus 53.13, and this angle would be 126.87. And when you find the tangent of 126.87, you get negative 1.33, which is actually what this is, right? 1.33 is just the opposite sign. So the point in showing you this is to say this. If we know this angle in the triangle, then we actually know the value of this angle also, but we are not 100% sure of the sign, so we'd have to check the sign. So the reason that we're doing that is to show you that when I draw an angle on my coordinate plane, I can use this part of the angle as a reference to finding the tangent of the angle that I drew. So what they did here was they drew an angle here on the coordinate plane. It's hard to see it, but it was right here just like that. That was the angle. Then they formed a right triangle with the x-axis. So they went straight down to the x-axis and straight over to the origin. And they formed this right triangle right here. You can literally count the numbers on this side. 1, 2, 3. Do you guys agree with me that this length is 3? Yeah? And what's this length? 1, 2, 3, 4. Now tell me this. Was this length directionally positive or negative? Negative. Was this length directionally positive or negative? It's positive, right? So when I found the tangent of this, which is exactly what I did over here, are you seeing that I found the tangent over here of this exact same triangle? When I found the tangent over this, do you see how it has the right signs on it this time? Because I talked about direction in my triangle. From the origin, which direction did I go? I went negative here, I'm positive there. So the tangent of this is 4 over negative 3, which is exactly the way we got it on the other problem. But it was way easier this way, wasn't it? To use the directions on the x and y axis. Okay? So, and if I needed to find something besides tangent, if I needed the cosine, couldn't I just find the hypotenuse by doing a squared plus b squared equals c squared and find this value over here in order to do that? Okay? So what we're doing here is we're going to find the trig functions of general angles. So we're going to just draw the angle that we're asked to do. We're going to make that right triangle, and then we're going to find the angles. So interestingly enough, in the past, and just to kind of reiterate, we called this the hypotenuse. Okay? Because of a squared plus b squared equals c squared. It's the opposite side, or the opposite of the right triangle, so it's the hypotenuse. Now when we're doing it on the coordinate plane, we're going to call it the r value, okay? Which really is the radius of the circle that this angle would be going through. But we would have x squared plus y squared equals r squared. So it's still the Pythagorean theorem. Are you seeing how it's still the same thing? But we would do our x value squared plus our y value squared, and that would equal the radius of our circle that would go through this point up here for our r squared. It's really just our hypotenuse. So we're not changing anything. We're just kind of looking at it with some different variables. So down here, it tells you that the sine is y over r. But it's still really from that angle, the opposite over the hypotenuse. You can still think about it that way. We just change it to y over r. Okay, the cosine is x over r, and the tangent is y over x. Okay, and then again, y or x can't be 0 because then it would make this undefined, which will happen sometimes. So what we're going to do here is practice doing that with an angle that they give me. So it tells me the terminal side of an angle in standard position contains the point -4, -8. So we're going to find the exact trig values for that. So I'm going to go over -4 and down -8. And that's where my ordered pair is going to be. Okay? My angle goes through that spot. Now, if I wanted to draw my whole angle, I would draw this side with my initial side, and then this is my terminal side, right? Okay, I'm going to draw a right triangle to the x-axis from the point that's on my angle. So from here, I'm going straight up to form a right triangle with the x-axis. because your triangle is always formed with the x-axis. You following me on that? Okay. Do I know how long this side is right here? -8. Do I know how long this side is right here? -4. And can I find how long this side is right here? I can. It's -4 squared plus -8 squared equals, and we're just going to say r squared from now on because it's that hypotenuse when we're talking about it on the coordinate plane is always going to be the radius of a circle that we're talking about. We just are not drawing the circles yet, and we're going to get into showing you that again in a little bit, okay? So 4 squared is 16, -4 squared is 16, -8 squared is 64. Add those together, and you get, is it 80? So r squared equals 80, square root both sides. So r equals the square root of 80. That actually simplifies a little bit to be 4 square roots of 5. So this side is 4 square roots of 5. You guys following me with how I got that? All right, so they want me to find the sine. Now the sine they told us would be our y value over our r value. So our y value is -8. And what's our r value? 4 square roots of 5. We can't leave a square root on the bottom though, so we'll have to simplify that. But I want to bring a point up right here. This is the angle that I drew. You guys agree with me that that's the angle that we drew, this big one right here, but it would be this little piece of it in our triangle. Isn't that still the opposite over the hypotenuse? So has the rule changed? No, we just write it with x's and y's to try to get our directions correct on it. But most of the time when I do it, I still do opposite over hypotenuse because it works better in my brain. Okay, did you guys punch that in your calculator and let that simplify it for you? The fraction of -8 over 4 square roots of 5. When you do that, you get -2 square roots of 5 over 5 for your solution. So that's the sine value of the angle. I just typed it in like this in my calculator exactly the way it was, and it rationalized the denominator for me. All right, if I'm going to find the cosine of that angle, the cosine is your x over your r, which is also still your adjacent over your hypotenuse. So you'd have -4 over 4 square roots of 5. You can punch that in your calculator and it will rationalize the denominator for you. I got -square root of 5 over 5. Is that what you guys got? And then the last one is the tangent. The tangent would be the opposite over the adjacent, which is still the y over the x if you use the new rules. So -8 over -4, which is a +2. So what we really did was we used the angle to draw the triangle. We used the triangle to find the sine, cosine, and tangent of those angles. And do you see how the direction made your signs correct on your sine, cosine, and tangent? So before, when we were just drawing our triangles, like when we do right triangle trig, we don't teach you about directional stuff because we're really only dealing with one quadrant. Now we're going to deal with all 4 quadrants. Okay? So, here we go. Draw the terminal side of an angle at the point 2, -5. So I'm over 2 and I'm down 5. And my point goes right there. That point is my angle. So I would have started here and I would have come this direction for my angle. You guys following me on how my angle would be drawn? It goes through that ordered pair. But I'm going to draw a right triangle using that, and my right triangle always gets drawn to the x-axis. So from that point, I'm going straight up to the x-axis to draw my right triangle. So here's my